So what are the different types of the aluminum alloys? Okay, so first one is aluminum copper alloys. So in which the aluminum is the parent element and copper is your alloying element. Okay, so aluminum copper alloy are a category of aluminum alloys in which copper is the primary alloying element. I have already told you that whatever the element in the mixture having the more volume fraction is take the name of that particular alloy, right? So here it's a aluminum alloy. Why? Because the volume fraction of aluminum or is a more as compared to the other element which has been mixed in aluminum, right? That's why it takes the name aluminum alloy. Okay, similar to that, if we have upper copper nickel, it means the copper has a higher volume fraction and nickel has a small volume fractions. Okay, so primary alloy element. These alloys are known for their high strength, excellent hardness, and good fatigue resistance. Okay, so we know what is strength. We have discussed many times. Excellent hardness. Hardness we have discussed as well. The good fatigue resistance. Fatigue resistance means the resistance of a material when they are experiencing a fluctuant load. Means suppose you are applying a load and removing the load, applying the load, removing the load. This is the fluctuation load, or you could say, I mean, the overall a dynamic load when we are going to our we are when we are going to apply a dynamic load of four types: fluctuation load, alternative loads. Okay, these all are the types of dynamic load. So in dynamic load conditions, where we are basically having a different kind of scenario where the material gets failed very early as compared to the normal loading. Okay, so when if you have the normal loading, then our material will get failed when they are either reaching a yielding point or a fracture point, or you can say ultimate point. In ductile material, we are having the yielding point, and in a brittle material, that we are having the ultimate strength, ultimate stress. Okay, but whatever the material that we are taking as our application part, the same material will fail, having a more load when they are having the normal loading. But the same material and the load, if the load application is changed, like they are having dynamic load, or in you say the fluctuating load or alternative load, then it will get fail very early, and that is known as the fatigue load or fatigue you know fatigue failure, right? So to save the material when they are in dynamic load conditions, and then they can resist that kind of failure, is known as a fatigue resistance. Okay, and across the all the application of mechanical engineering, uh, you know most of the times all the component is experiencing a fatigue load or fatigue failure. So fatigue design is very important when they are come to get in the practical life. Most of the element are experiencing the fatigue load. So material must be having of fatigue resistance so that their component can run for a many for higher durations. Okay, so they can have a more life, right? So making them widely used in the aerospace, automobiles, and structural application. Why these are taken example? Because in automobile it's very obvious. Okay, yeah, you can think about, I mean, all the shafts that are being used in automobile that are of having the fatigue resistance. I mean, they must having the more fatigue resistance. Okay, a structural also, and aerospace. This is the aircraft and all that. Okay.